Okay, let's practice graphing a cubic. Now this cubic clearly only has 3 terms here, and so we're going to go through the whole process of factoring, but we won't need to do synthetic division because if you really look at this more closely, you can see that there's a GCF we can take out. So our whole point here is kind of to do what we've done in previous videos where we found the zeros, we want to know the multiplicities, we want to use the end behavior and graph, kind of sketch this function. It's not going to be perfect unless we just, pick a whole bunch of points and plug it in, but this will at least give us a general idea of what the graph should look like for this function. So we're dealing with the function f of x equals x cubed plus x squared minus 6x. So our first step is if it can be factored, let's factor it. So as I mentioned a second ago, there is an x in common with all of these. So we're going to factor out an x. And then that's going to give us, again, dividing by x for all of these would be x squared plus x minus 6. And as I've done many times in previous problems, I'm going to bring down that first x so we don't forget it. And then we're going to factor this x squared plus x minus 6. If you want to do it kind of the short way, that's fine. I'm going to do it by grouping. So let's do x squared plus blank minus 6. And we are looking for the factors of negative 6 that give me 1. So we are looking at 3 and 2. And 3 is going to be positive. 2 will be negative. And that's going to give me 1 and negative 6 when we multiply. I'm going to put the negative first. I think you all know that by now if you've seen some of my videos. So this is negative 2x and plus 3x. And then we're going to factor by grouping. So in the first group, we have an x that's coming out. X squared divided by x is x. And then negative 2x divided by x is negative 2. In the second group, we have 3 coming out. 3x divided by 3 is 3x. And negative 6 divided by 3 is negative 2. I'm sorry. 3x divided by 3 is just x. And negative 6 divided by 3 is negative 2. There we go. And how do you know, right? I was halfway and went, oh, wait, these don't match. Okay, so you still are looking for that as you factor. All right, and then we have our final factors. We've got our x out front, and then x plus 3 and x minus 2. Okay, so from here, let's do our zeros. So our zeros will be, I'm not going to go through the process of setting each one equal to 0. Let's see if we can just do this without doing that. So our zeros are going to be the x values. Remember, if you set x equal to 0, that's 0. X plus 3 equals 0 gives you negative 3. And x minus 2 set equal to 0 is 2. So those are our zeros. Now, let's consider multiplicity real quick while we're talking about this. So go in and put your exponents on each factor. Remember, this is just going to be a 1, this is a 1, and this is a 1. And remember, your degree of the whole function is going to be adding up those multiplicities. So 1 plus 1 plus 1 does indeed give us that 3 to make this a cubic, okay? Now, what does this mean in terms of the graph and for each zero? Remember that if it is an odd multiplicity, then on the graph, it passes through. So every one of these are going to be a pass-through on the graph. Every one. All right. So coming down to our blanks, we have that, what's first asking x-intercept. So we have our zeros. Let's turn those into x-intercepts. So this would be 0, 0, negative 3, 0, and 2, 0. Did not leave myself very much room there, but that's okay. Now let's talk y-intercept. It's been a little bit since we've talked about that, especially since maybe lines. And let's think about how we found the y-intercept with lines. And also how we're looking at x-intercepts. So x-intercepts are when the y values are 0. Y value equals 0, right? And you can see that in every one of our points. Well, obviously the y-intercept would be the opposite. So this is when the x value equals 0. So I'll go through this process one time and then we'll kind of talk about what it should look like if we have a standard form of the function like we do in this one. And so if we are trying to find the y-intercept, that is when x is 0. That means I'm doing f of 0. So in this case, I am actually plugging in 0 into the function. So we've got 0 cubed plus 0 squared minus 6 times 0 Guess what that's going to give us? It's going to give us 0. So that means that our y-intercept is also 0, 0. And honestly, we could have seen that from our x-intercepts. If 0, 0 is in the x-intercepts, that same thing is the y-intercept, because that is the only place where that would be crossing both the x and y axis. So if it's crossing one, it's crossing the other at the origin. Okay, so again, if you have the origin as an x-intercept, that will be the y-intercept. You only have one y-intercept, okay? All right, and lastly, all this other stuff is asking end behavior. So let's go back. End behavior is going to be based off of leading term. So our leading term is the term with the highest degree. In this case, we have x cubed, and it's positive. So that means positive right side goes up. Odd tells me to do the opposite on the left. So this first one is saying as x approaches infinity, that's right side. Y approaches what? And this is going up, so it's going to infinity. And as x approaches negative infinity, that's left. Y approaches what? Well, this is going down, so that is negative infinity. So now we got all of our blanks, and now we need to actually sketch this. So I would start by graphing your x-intercepts. So we have our x-intercepts as 0, 0, negative 3, 0, and 2, 0. Okay, now end behavior, let's talk about that. We're going to put that in here. So end behavior means that from the, let's look at the right side first. From the rightmost x value, or x-intercept, it's going to go up. So we know this is going up. Okay, we'll extend that out once we kind of get the general idea of the graph here. On the left side, we know that this is going down from the leftmost x-intercept. So this is going to go down. All right, so the other thing we know is that for every one of these, they're passing through. So none of these are bounces. They're all just going straight through. So that means this is kind of going straight through this way, and this is kind of going straight through this way. And since these have to all connect, then I'm going to go ahead and tell you that this is going to go through this way. So we know this kind of is going to go down that way, and the right side goes up. And if you want to know what happens kind of here in the middle, this is where you can actually remember, this is the crucial thing about functions, is that you can pick any x you want and plug it in, and you get your y value. So if you want to know what happens and how high up it goes kind of in this area and how low it goes in that area, you could actually pick any point you want and plug it in. I'm going to just kind of sketch this out. It's going to kind of look like this. That's generally what a cubic looks like. But maybe I'll show you real quick what I mean by plugging it in. So maybe I want to know how far down that goes. Let's pick the x value of 1. I'm going to erase this just for a moment. And if my x value is 1 and I plug it into this f of x, that would be f of 1, would be 1 cubed plus 1 squared minus 6 times 1. So that's going to be what? 1 plus 1 is 2. Minus 6 is negative 4. So I have the point 1, negative 4. And keep in mind, this is in, if you look at the graph carefully, it's in the y-axis is every 5 units. So 1, negative 4 would be somewhere around here. And that's how low that would go. Okay, you could do the same thing. Again, I'm not going to do that, but you could do the same thing for negative 1 and negative 2. So the reason that I have sketch here is that, again, we don't have this perfectly, but we have a pretty good idea of what this graph is going to look like given all of this information.